clearer? So this is basically a section view of waterlogged area as well as subsurface drainage system. So as you all know that globally around 80 million hectare is waterlogged and saline and sodic affected area. So we have to reclaim all those lands so as to have more productivity, as because our country is the most populated country and we need to fulfill the demands of each and every person in our country. So as you can see, this is a section view of waterlogged area over here, which is salt encrustated, that is salt accumulated area. It is affected by salts, alkalis, and it is also waterlogged area. This is a kind of uncultivated land which need to be cultivated so as to increase the productivity. So for this we have the best reclaiming methods. In that, one of the best effective method is the subsurface drainage system. So we have different steps involved in installing the subsurface drainage system. So firstly, we will start by surveying the land. So for that we require an agricultural engineer to survey this land. He basically takes out a contour map, and from that contour map we get different contour lines on which we can lay out different main line, lateral trenches and all. So for that we require the contour mapping. So firstly we will start by laying the main drain line, which will start from the nala, that is the outlet, to the main line, that is upstream. It goes from the nala to the upstream. You would be wondering that why we start from the nala to the upstream. It is just to check the elevations. The elevation should not be too high or too low, because if it becomes too low then siltation may occur. As you can see, this is a live project which was done under our course teacher Premanand sir. He executed this project in 17,000 acres land, and in that you can see this is the live, we have done the replica of that particular project over here. This is the nala, nala deepening for getting free fall elevation. As I mentioned before, that it starts from the lower to higher, like we have to have the optimum elevation, because siltation may occur, and to get free fall we have to start from the outlet. Then we will make the lateral trenches. These are parallel or herringbone in shape. So these trenches are excavated either manually or by using these JCBs and all. As you can see here, we have also demonstrated in that. After this, in this lateral trenches we use different pipes which are perforated and corrugated. As you can see there, we have covered that particular pipe with synthetic filter, synthetic fiber or coir pith. You can also use coir pith. This particularly is placed over here in these trenches. The water moves into these pipes. The water which is moved into these pipes has to be filtered, because so that to reduce the clogging or to avoid clogging. So these coir piths are used for that particular reason, so that there is no clogging over there. After that, these particular pipes are connected to these inspection chamber. These are inspection chamber which you can see here in the main line trench. All the pipes in the lateral trenches are connected to the inspection chamber. It is also called as manhole. It is to check whether the water is flowing inside the main line correctly or not. So this is the major purpose of these inspection chamber. After then we will backfill the soil, that is we will refill the soil, the excavated soil. This particular process is called as backfilling. Then the major thing which should be kept in mind during excavating all these trenches is the spacing. The spacing between all these trenches is depends upon the soil type, the clay content present in the soil type. So for clay content, for clay soil, it's about 20 to 40 centimeter of spacing, 20 to 40 meters of spacing, and for sandy soil, it's about 40 to 90 meter of spacing, which we do basically. And this is all about the spacing between the trenches. After then we also need to keep in mind about the depth of the excavation which we do. That is around 1 to 1.5 meter for clay soil, and for sandy soil it is around 1.5 to 2 meter, and it varies according to the soil type. After then we refill the soil, that is backfilling, as I mentioned before. Then this is the subsurface drainage installation method. This is the major view of this particular method. Then we have this reclaimed land over here. This is the live working model of the subsurface drainage system, in which you can see that the paddy is grown over here. You can also see in this executed project that the land was particularly like this when it was waterlogged, saline affected, salt affected, and after doing all this process, after establishing this subsurface drainage system, we have the final view of this field as this one, the paddy crop. Similarly, we have demonstrated the same view here in real model. So we can also show you the demonstration.
To start the outlet,
This is the outlet pipe.
how the water is draining it out.
It is like from this all these inspection chamber, the water is draining out into the nala. That is the outlet. So this is the particular view of how the subsurface drainage works. It also removes the water as well as the dissolved salts in the water, which is definitely a very good advantage for growing different crops, majorly paddy, as it is a waterlogged field only we require. But sometimes what happens is saline, it is salt affected and all. So for that we require subsurface drainage system. As our country has so much of waterlogged areas, we have to reclaim all those lands so as to increase the productivity, because our country population is increasing day by day and we have to fulfill their needs. So for that, I think so this is the most effective method which we have to use, and each and every farmer should know about it. And around 40,000 to 75,000 rupees per hectare is like spent on this particular project, like subsurface drainage system. You can use this in your field. Thank you.